Hi everyone, this session we are going to cover velocity time graphs. Case 1, velocity time graph for a body moving with uniform velocity. We are going to check the graph for time interval 0 to 5 seconds and velocity range I have taken 10, 20, 30, 40, 50, 10 meter per second. So the initial velocity of the body is 40 meter per second, and as the object is covering the same distance and same in the same time interval, it is said to be in uniform velocity. So for second also the body is covering 40 meter per second. The third second the velocity of the body is 40 meter per second. Fourth second also same, fifth second also same. So if we join all these points, we are going to get a straight line parallel to the time or x-axis. So shape of the graph is a straight line parallel to the time axis. So if we find the slope for this graph, what we are going to get? So velocity versus time graph will give us acceleration, because the y component is velocity, change in velocity, and x component is time. So change in velocity by time is nothing but acceleration. So I'm going to take two y coordinates, any two you can choose. I'm taking, because all values are same, 40. So I'm taking the values on 3 and 2 seconds respectively. So this point is y1, y2. y1, y2 I have taken, both are 40 meter per second. x2, x1 are 3 and 2 seconds respectively. So substitute the values 40 minus 40 by 3 minus 2. That will give us 0 by 1, which is 0 meter per second square. That is the acceleration that we got from for the uniform velocity. If we found the displacement in 5 seconds, so displacement is nothing but the area, here you all can see here shaded area. So the shaded area under the rectangle shape, that is OABC. So area of the rectangle OABC. We all know that the area of rectangle formula, length into breadth. So if you consider the length of the rectangle as OC and breadth of the rectangle as OA, OC into OA. So along x-axis we took time, which is 5 seconds, times OA is nothing but 40 meter per second. So 5 into 40, which is 200 meter. This is the distance or displacement covered by the vehicle within 5 seconds. Now case 2, velocity time graph for a car moving with uniform acceleration. The previous case is uniform velocity. Now we are going to study about uniform acceleration graph. So again, I am taking the time interval 5 seconds, 5, 10, 15, 20, 25, and velocity 10, 20, 30, 40, 50, 60, etc. When t is 5 seconds, velocity of the car is 10 meter per second. When time is 10 seconds, 20 meter per second, and so on. Like that, if you put on the values here, we are going to get a straight line passing through origin. Shape of the graph is linear or straight line. OA, if you name, OA is a linear or straight line. Coming to the point of slope, again we are already aware of velocity versus time graph gives us acceleration, that has been given here. Acceleration is equal to change in y components or y coordinates by change in x coordinates. We have taken here 40 and 10 as y2 and y1. Similarly, 20 and 5 as x2 and x1 coordinates respectively. If you substitute and simplify, we are going to get 40 minus 10 by 20 minus 5, which is 30 by 15, 2 meter per second square. This is how we can calculate the acceleration of the car. Next, the distance traveled by the car is equal to area under OAB. You all can see the shape of OAB is nothing but the triangle. Therefore, area under OAB nothing but area of the triangle OAB. So that can be given by half into base of the triangle is nothing but OB times height of the triangle is nothing but AB. So we all know that area of the triangle is nothing but half base times height. half into base OB is nothing but 25 seconds and height AB is nothing but 50 meter per second. So if you simplify this, we will be getting 625 meter as the answer. Case 3, velocity time graph for a car moving with uniform retardation. So in this scenario, car is retarding at regular intervals because we have mentioned uniform retardation. So at 0 seconds, the car is already moving with speed or velocity of 30 meter per second, and then in next 1 second gradually decreasing by 5 meters per second. You can see here 30, 25, and then 20, 15, 10, 5, like that. So for 1 second, the velocity of the car is 25 meter per second. For 2 seconds, 15. For 3 seconds, 5 meter per second. So if you check the shape of the graph, we are going to get again a straight line or linear. To find the slope, let us take the y coordinates difference by x coordinates difference. Nothing but here now y1 is the first coordinate and y2 is the end coordinate. Of course, we can take any two, but this is the y2 I have taken as 0 because this is the final point. Y1 I have taken as 30. So y2 minus y1, 0 minus 30 by the corresponding time values 4 minus 0. That will give us negative 30 by 4, which is minus 7.5 meter per second square. So this is the acceleration we got, or retardation we always say without the negative sign, which is 7.5 meter per second square. This is the retardation of the car. Next, the distance covered by the car is equal to area under OAB. Just like the previous case, we have to find the area that has covered under OAB. This all shaded area is nothing but the distance covered by the car, which is given by half into OB, base into OA, height. Substitute the values. Half into base is nothing but 4, OA is nothing but 30. If you simplify this, we are going to get 60 meter. Case 4, velocity time graph of an object non-uniform, of an object with non-uniform retardation. So if we plot a graph between time and velocity, again in this scenario the velocity keeps increasing and decreasing at regular intervals, or maybe the velocity remains constant for unequal time intervals, or velocity keeps changing with respect to the time, increasing as well as decreasing. That is the reason why we are going to get the graphs as a curve or non-linear shape. Sometimes even we can say like a zigzag path. That these are the 4 different graphs for velocity versus time.